Hello Math 7 students, this is Open Up Resources Unit 2, Lesson 7, Comparing Relationships with Tables. To get us started, we are actually going to go back and do this quick poll. You have this table, write the equation for the relationship that you see in the table. Pause the video now so that you have enough time to think and do this. All right, let's talk about this. The correct equation is y equals 1/5 x. In order to answer these equation questions, we always need to figure out what's happening in the table. And to answer that, we want to know, how do we go forward? How does a 5 change to a 1? How does a 20 change to a 4? And although in the beginning you might recognize that we can simply divide by 5, we always want to be treating these types of questions as multiplication. So we should recognize that dividing by 5 is the same as multiplying by 1/5. 20 divided by 5 is 4, but changing it to multiplication, 20 times the fraction 1/5 is equal to 4. So now that I've identified that constant of proportionality, I simply use that constant of proportionality to say, if we have an x in the first column, we simply multiply that x by 1/5, and it gives me the y value that's in that second column. And so that gives us the equation x times 1/5 is equal to y. And of course, equivalent versions of this are y equals x times 1/5, y equals 1/5 x right here, or even 1/5 x is equal to y. So all of those are different versions of the exact same equation, looking at using that constant of proportionality that we've been working so hard on finding and using it in our equations. So now with that in mind, we're ready for lesson 7. We're going to quickly review what makes ratios equivalent, how we can tie that into proportions so that we can find some times where maybe they're not always going to be proportional. So we have the situation, adjusting a recipe. A lemonade recipe calls for 5 lemons, 2 cups of water, and 2 tablespoons of honey. You are going to invent 4 new versions of this lemonade recipe. The first is one that is going to make more lemonade, but it's going to taste exactly the same. Another recipe that will make less lemonade, but will still taste exactly the same. One that will have a stronger lemon taste than the original recipe, and one that will have a weaker lemon taste than the original recipe. So pause the video long enough to get your 4 recipes written, and we'll come back together here soon. All right, give me a recipe that is going to taste the same, but is going to make more lemonade. Carter. Okay, 10 lemons, 4 cups of water, and 4 tablespoons honey. And how do we know that they're going to taste the same? Seth. Yep, we just multiplied the original recipe numbers by 2. This was multiplied by 2, this was also multiplied by 2, and this was multiplied by 2. Now give me a recipe that's going to taste the same, but isn't going to make quite as much. I want less. Let's go, Gabe. Okay, and so how many lemons will that be if I divide the original recipe by 2? Good. 2.5 lemons, 1 cup of water, and 1 tablespoon of honey. I guess I should do that up here too. 4 tablespoons honey. Okay, now give me a recipe that is going to have a stronger lemon taste than this original recipe. What did you do, Dex? Okay. Great. We just added an extra lemon, guaranteeing that we're going to have a stronger lemon taste, but we kept the rest of that recipe the same. And what about a weaker lemon taste? Siley. Good. 4 lemons, 2 cups of water. I did it again. 2 tablespoons of honey. So we're reducing the amount of honey, but keeping everything else the same, guaranteeing that it will taste less lemony. 2 tablespoons of honey. All right, now let's start this lesson. Visiting the state park. Entrance to a state park costs $6 per vehicle, plus $2 per person in the vehicle. There's some information that we haven't dealt with before. It costs $6 per vehicle plus $2 per person that is inside of that vehicle. So we need to fill out this table. How much will it cost for a car with 2 people in that car, 4 people in that car, or 10 people in that car? I'm going to have you guys pause the video, give this a try, because I'm hoping that there's going to be some mistakes made that we can learn from. So pause the video, give it a try, and then we'll go over it. All right, 2 people in the vehicle. What's the total cost? I've heard from everybody. Let's go with Hayden. Peyton, I knew it. $10. How did you get that? Good. So these people are going to be the 2 times 2. That's just what we're paying for the people, but that's not the only thing we have to pay for. We also have to pay the extra $6 because they're all sitting in the same vehicle. So 2 times 2 is 4 plus 6 is 10. Okay, 4 people in the vehicle. What is that going to be? Dean. And how did you get there? Good. So 4 people in the vehicle now, each of them costing $2, plus that $6 because they're all in that same vehicle. And so now 4 times 2 is 8 plus 6 is $14. What about 10 people? Now this is going to have to be a bigger vehicle, right? But 10 people are squeezing into that vehicle. Let's go with Seth. How'd you get there? $10 times 2 plus 6 is equal to 26. 10 people times the $2 per person plus the $6 for the vehicle going into the state park for 26. So for each row in the table, if each person in the vehicle splits the cost entrance equally, how much will each person pay? So we have 2 people in the vehicle. The total cost is $10. How much is each person going to pay? This first row is going to be 10 divided by 2, which is equal to $5. $5 per people, per person. Okay, what about this row in the table? $14 split 4 ways. Gabe? $3.50 per person. And what about this one? 10 people. $26 split among 10 people. That is going to be, Peyton, $2.60. That's interesting, isn't it? I want you to think about what we've done in the past when we've done this and we've done this division. We've gotten the constant number all the way through. Here, it's going to be $5, here $3.50 per person, and here $2.60 per person. That's going to be coming into play in a little bit. Question 3 is, how might you determine the entrance cost for a bus with 50 people? Essentially, all we're doing here is saying, okay, well, what if there's 50 people in one single bus? What is that cost going to be? Talk to each other. Okay, that was quick. So who has the answer? How much is it going to cost? Good, thank you, Danielle. And how did you get 106? Uh-huh. Good. Even though it's a bus, it still is just one vehicle. So we'll add that and we get $106. What if these people all split the cost? I'm just curious, what is that going to be? It's not asking for it, but what if these people split the cost? 106 divided by 50 people is equal to Dax, $2.12. So, is the relationship between the number of people and the total entrance cost a proportional relationship? Again, I want you to talk to each other. Think about what the definition of proportions is. Think about the characteristics we've seen before. Give you about 30 seconds to discuss. Ready, set, go. All right, I'm hearing some really good discussions across the room. Sounding pretty good. Let's just take a quick vote. Who says yes, it's proportional? I didn't think so. Who says no, it's not proportional? Good. Now I want to know the reasons why you're saying no. You're correct, but let's talk about why. Tell me some things that you noticed, Carter. Good. Let's write that down. No. Because if it were proportional, dollars per person would be the same. I'm going to say the cost per person. Cost per person would be the same, and it's not. Who has another justification of why this is not a proportional relationship? Dax. Mm-hmm. Good. You are recognizing that because we're doing something else. So interestingly enough, we are multiplying by 2 every time we go across the table, but that's not the only thing we're doing, right? We're multiplying by 2 and then we're also adding 6, and it's that adding 6 for the cost of the vehicle that's screwing things up. So if I were looking for a constant of proportionality, I would say 2 times 5 is 10. 4 times 350 is 14, and 10 times 2.6 or $2.60 is equal to 26. So we could also justify this as seeing that we have different constants of proportionality, or therefore there isn't a constant of proportionality if it's not constant. And I know you guys, it's tight. You don't have a ton of space there. I do, so I'm going to give myself some extra space because I did split these up. Because I want to write as much as I can, as many justifications as possible. No constant of proportionality. And although we multiplied by 2 going across, we also added 6, and that's where things got to be crazy. Okay, once that's written down, go ahead and look at the "Are you ready for more?" This is a question that you as 7th graders don't have to be able to answer. You don't have to write an equation for this relationship, but I want to see if you can try it, because we've kind of built it up enough that I think that you probably can. What equation are you going to use to find the total entrance cost for a vehicle, so just one vehicle, with any number of people. Take about 20 to 30 seconds talking with your group. See if you can write an equation for that. I'm loving these discussions that I'm hearing. And since they're still going, I'll give you a little bit of extra time. These are great discussions. Seth, do you know? Is that why your hand's raised? Okay, put it down for a second. Let everyone else finish those discussions. We'll come together in a second. All right, let's go over this then. And I heard a lot of discussion on variables too. Let's just make it easy and say P for people, and we'll say D for dollars. So if I'm going to use P for the number of people and D for the total cost in dollars, what is this going to be? Seth? You got it. P times 2, because however many people, we just have to multiply it by 2 because that's going to be the cost for the people. But we're not done because we also have to pay for that vehicle, so plus an extra $6, and that's going to be the total dollar amount, D. P times 2 plus 6 is equal to D. How many of you came up with the similar relationship or equation, just maybe different variables? Fantastic. Okay, that's an 8th grade level problem. So for you guys to be able to write that is pretty awesome. Well done. Now, let's move on, because we have now seen a relationship, and there was a relationship, right? It was even predictable enough that we could write a pattern, but we've seen a relationship that is not proportional. And so I want us to be able to look at relationships, look at a situation, look at the tables, and identify when it's going to be proportional, and when it is not. So Han and Claire were running laps around the track, and the coach recorded their times at the end of laps 2, 4, 6, and 8. Here's Han's run. You can see it recorded in the table. Here's Claire's run, recorded here in the table. We want to find the minutes per lap first, because it will help us answer the remaining questions. So I'm just going to give you guys maybe 2 minutes to complete this whole section, complete those tables, answer question 1, answer question 2. Students in person are working with their groups, and online learners are pausing the video to work through these problems. Ready, set, go. All right, we've all had a chance to look at this, so now this is just going over those answers. Let's call out these answers quickly. Minutes per lap, I can do that one easy. That's 2 minutes per lap. This one I can also do easily in my head. 9 minutes, 4 laps. That's going to be, I thought I could do it in my head. I cannot do it in my head. Danielle. 2.25, thank you. And 15 minutes and 6 laps, Gabe. 2.5, thank you. And 23 minutes, 8 laps, Dax. 2.875, thank you. Is Han running at a constant pace then? No. Is Claire? Well, let's see. 5 minutes, 2 laps, that's 2.5 minutes per lap. 10 minutes, 4 laps, that's another 2.5. What about this one? 15 minutes, 6 laps. 2.5, 20 minutes, 8 laps is 2.5 minutes per lap. Is Claire running at a constant pace? Yes, she is. How do you know? Because we did the work, right? Because this is the same. 2.5 minutes per lap everywhere. This is a number that's changing, so not the same. I'm not going to waste my time writing it down because I want to be able to finish this lesson. I think that the work is a great enough explanation there. So, write an equation for the relationship between distance and time for anyone who is running at a constant pace. We don't need to worry about it for Han because he's not running at a constant pace, but Claire is. So what is that equation going to be, Gabe? Okay, I like it. That is going to work. What he said for online learners who didn't hear, D divided by T is equal to M for minutes. And I just have to say, I actually really, really love this process that you went through right here, where you took the time to define the variables and you said, for time, I'm going to use T. For distance, I'm going to use D. And defining those variables is fantastic. And the minutes per lap is M. But here's something that is a little bit unnecessary here. Is the minutes per lap changing? The minutes per lap is always 2.5. So do I need a variable for something that's always going to be that same thing? Nuh-uh. Are these all the same? No, those ones are changing. So I don't need to waste a variable here because I know that the minutes per lap is always going to be equal to 2.5. So yes, we could have written the equation D divided by T is equal to 2.5, but I don't love this equation. It's not wrong. It's just not one that I love, because I want us to write the equations in the same way that we've been doing, in the same way that we did for our warm-up, which is asking that question, how does a 2 change to a 2.5? We already know it, right? I gave away the answer. I was so excited about the answer that I gave it away. I didn't ask the question right. How does a 2 change to a 5? By multiplying by 2.5. How does the 4 change to a 10? Exactly. So what's the constant of proportionality? Also the same as the unit rate. Yep. Also the same as the answer. So when I take that D in the first column, I move forward into the second column by multiplying by 2.5, and that gives me the T for time. Does that make sense? Okay. Is that right? D distance times 2.5 is equal to T the time. Great. Okay. So is this one wrong? No. Is it my favorite one? No. Is this one my favorite one? Yeah, I like that one better. But they're both right. Okay. So in your packet, for those who printed the packet and are learning online from home looking at the packet, it does go to the cool down next, but I want to summarize first and then we'll go to the cool down. So summary, we are highlighting. Here are the prices for some smoothies at 2 different smoothie shops. We have Smoothie Shop A. It shows 8 ounces. It'll be $6. 12 ounces will be $9, and so on. And it has already even calculated the dollars per ounce for us. In Smoothie Shop B, we have an 8-ounce smoothie, which is $6, same as the other place, so 75 cents per ounce. We have a 8-ounce smoothie that's going to cost, no, I said that backwards, a 12-ounce smoothie that's going to cost $8. That makes it 67 cents per ounce. 16-ounce smoothie for $10, that's $0.625 per ounce. Which one of those is proportional? A is going to be the one that's proportional because it has a constant dollars per ounce. And if it has a constant dollars per ounce, guess what that means? It has a constant of proportionality because it's the unit rate here. And here, these are all different unit rates. And so we don't have a constant of proportionality. So for Smoothie Shop A, smoothies cost 75 cents per ounce, no matter which size we buy. There could be a proportional relationship between smoothie size and the price of the smoothie, and that equation is P equals 0.75 S. Where, and this is what Gabe did, which I really appreciate, where S represents the size in ounces and P represents the price in dollars. They defined the variables. They said, I'm going to use S and this is what S means. I'm going to use P and this is what P means. And I like taking that step. The relationship could still not be proportional if there were a different size on the menu that did not have the same price per ounce. But based on this information and this menu that has been given to us, it is proportional. If they were to squeeze something else in there, that might change it. But with this information, it is a proportional relationship. And this one, Smoothie Shop B, the cost per ounce is different for each size. So here the relationship between smoothie size and price is definitely not proportional. That's worth noting. Here the relationship between smoothie size and price is definitely not proportional because the cost per ounce is different for each size. When it's different, It's not proportional. In general, two quantities in a proportional relationship will always have the same quotient. And again, I want you to understand why they're always going to have the same quotient. That same quotient, ultimately, what we're calculating is the unit rate, because we're finding the price per ounce. And the unit rate is the same as the constant of proportionality. So if they have that same quotient, that means they have the same unit rate. If they have the same unit rate, that means that they have a constant of proportionality and therefore are proportional. When we see some values for two related quantities in a table and we get the same quotient when we divide them, that means they might be in a proportional relationship. But if we can't see all of the possible pairs, we can't be completely sure. However, if we know the relationship can be expressed by an equation in the form y equals kx, then we are sure that it's proportional. So I want you to make sense of that by going all the way back to that original problem, the bus and the cars in the state park. Were we still able to find a relationship and even write an equation? Yes, but notice the form of that equation. It says p times 2 plus 6 equals d, or in other words, I could say 2p plus 6 equals d. I could rewrite that to be d equals 2p plus 6. Let's compare it to what it just said. They would be in the form y equals kx. So what if I'm using different variables? Are they in the same format? We have a variable by itself equal to something times a variable, and then we've got a plus 6. Do I have that option here in the proportional equation? No. And again, that's what we also decided, that plus 6, us having to add the $6, that's the part that kind of screwed up that proportional relationship. And so we are wanting to make this connection in what these equations look like, that we want our equations to be in this form, y equals kx. When it's in that form, then we know that it's going to be proportional. So I'm going to add a little comment to this. In our first problem where we were adding 6, we can't have that. So add a little note here. No extra addition or subtraction. If all we have is just this multiplication, then we're good. Just multiplying by the constant of proportionality, notice that I abbreviated there, then that's a good thing. And now it's time for our cool down. Apples and pizza. Based on the information in the table, is the cost of apples proportional to the weight of the apples? And then part 2, based on the information in this table, is the cost of pizza proportional to the number of toppings? Then I want you to write an equation for the proportional relationship. So hint, one of them is going to be proportional, one of them is not. You're going to write the equation for the one that is proportional. Work with your groups on this. Should take about maybe 90 seconds to 2 minutes. Ready, set, go. Online learners, pause the video to work through this and we'll come back together to discuss. Okay, so who thinks they know which one is the proportional one? Good. Which one is it? The left side. And I'm going to play devil's advocate. And I'm going to try and convince you that it's this right side. Because I can see that this is changing in a constant way. We are adding $1.50 every time. Adding $1.50. Is that true though? Am I adding $1.50? No, I don't. I can just add one. Are you sure? Look at this one. help me out though. What are we adding here? Do the calculations. What are we adding? Do the calculations. What are we adding? 90 cents? Thank you. What am I adding here? You're lying to me. We're not adding 90 cents. Calculate it again. Nice try. 5.64 minus 3.76. I'm adding $1.88. $7.52 minus 5.64. What am I adding here? Huh. How about that? What about here? 9.4 minus 7.52. Huh. Aren't these behaving in very much the same way? Dax? Okay. What is the constant of proportionality? Huh. Is it 188? Huh. That's interesting, isn't it? You said that we're never adding, but am I adding the constant of proportionality here? Yes, the constant of proportionality is across, and I'm so glad that you guys recognize that and really tried fighting hard with me on that. That really means that it's sinking in. But I do want to point out, though, that as I'm going across this table multiplying by 1.88, what do you also see is happening here? We're adding 188. Why is that happening? Because this is still something that I want you to recognize. Yes, this should be our focus as I go across the table. I'm multiplying by 1.88. But I also want you to recognize this and make sense of it. 3 multiplied by 188 is 564. So why is it 188 difference? Well, because it's an extra pound. How much is a pound of apples going to be? 188. So when I add an extra pound of apples, it makes sense that I would be adding 188. Does that make sense? Okay, so interpret that then. You can see that I'm adding 150 every time, right? So interpret that. What does that mean? That means the cost of a topping, one single topping, right? Because one topping is making the pizza cost $1.50 more. So is there a constant somewhere? Yeah, the constant somewhere is that a topping here is going to cost $1.50. But is there a constant of proportionality as I go across the table? No. Because here, it might be 2 times, help me out, 590, what is it? 599, 5? Yeah. And here, it would be, what is it, 4? Like that? Okay. Oh, 4 and 4, 6, 6, 7. 4 and 4, 6 repeating? Okay, I'll calculate it myself. Y'all are killing me. 13.49 divided by 3 is equal to 4.496 repeating. Are we multiplying by the same thing as we go across? No. So what is the equation for the proportional relationship? I'm going to just make it simple, and I'm going to go x and y. So this would be x times 188 is equal to y. We could also write that as y equals 188x. Is that 188 here important? Even here? Yeah. Is it the only thing we should be noticing? Definitely not. Yes, Gabe? We could, but not my favorite. Yes, we could do it your way, but not my favorite, so I'm not going to write it down. I want to only write my favorite way down. And your homework is the lesson 7, practice problems. That's it for today. We'll see you next time.